So what I'm going to do today is talk about a paper that I gave at the Carnegie Rochester NYU Public Policy Conference in earlier this year in April. And as was mentioned, so I was an academic for many years, from '87 through 2009. And then in 2009, I became the president of the Federal Reserve Bank of Minneapolis. And then I served in that role for about 6 years. And this was an outgrowth of my trying to put together two parts of my life, I would say, my academic life and the policy life. And the challenge was that as I went along in the public policy sphere, and I talked a lot to academics also about the rather difficult public policy questions we were facing, it seemed like we were not talking the same language, we were talking past each other. And I spent a lot of time trying to think about why. And this is, as I say, the outgrowth of all that. Okay. And I think that the challenge was that the question on the table in academic economics, macroeconomics, about public policy is really completely different from one we were facing as policymakers. And we saw some of that actually in Joanne's presentation, that modern macro is largely about the choice among different policy regimes and rules. Okay? It's not, and the goal here is a regime or a rule is going to describe not just what happens in a particular date and state. It's not just about one point in time and one eventuality. It's about how policy is going to be chosen not today and in all future dates and states. It's a specification of that. And the reason we do that, the reason, if we go way back in history, the reason we're doing policy that way in academic macro is because of Robert Lucas's ideas on this, which were very persuasively argued, as those of us anyone who's read the paper will say, and that unless you're in a rational expectations world, or even a world where policy people are just forward-looking, we need to have some way to control the beliefs of a forward-looking private sector. And this specificity of saying what's going to happen in every date and state is essential then. So this was Lucas's idea, so Lucas' critique. And in a macro context, these kinds of policy analyses of choosing among regimes and rules are now grounded in increasingly complex, I say hopefully structural. I mean, I'll leave my words for what they are. The idea, by the word structural, what you mean is the elements of the model are invariant to the policy regime comparison being undertaken. That they will, the elements of the model will not change as you change policy regimes. So that's why we do things like preferences and technology and price setting costs and all that stuff are in the model because those are the things that are supposed to be invariant to what the policymaker does. Now the problem is, I mean for academics it's a problem, that these policy analyses really have only limited practical relevance. I mean, it's a problem if you want to say something that's relevant about for policy choices that are being made in the world. If you're interested in the science of these particular regime comparisons, it's fine. But if you're trying to talk, as I was, between these two worlds, this is a real challenge because few policymakers are actually going to be undertaking these once and for all kinds of quasi-constitutional changes, changes regimes in a once and for all way. And absolutely, we can come with examples. And it's not to say that no choices of this kind take place. But at the same time, I think we have to admit that these are rare. The more realistic, I think, description, or more common maybe is a better way to say this, is that policymakers are asked to make one of a long sequence of choices. Like, as the choice we were often confronted with when I was at the Fed, like whether to raise or lower interest rates. But that's not the only one, of course. If you're in a country where the budget gets set annually, it's decisions about what should be done with taxes and spending as well would take this periodic form. Okay. So the question I'm going to ask here is, motivated by this, I want to consider a policymaker who's confronted with this kind of episodic choice of you're at a moment in time, you're one of many policymakers in a long sequence of policymakers. They're going to be making a decision. And how should he or she use the available data to arrive at an optimal decision today? And the way I'm going to be thinking about this is through the lens of game theory. This is a very standard way, of course, to model this situation, which is to consider a dynamic game between a sequence of policymakers and a forward-looking private sector, and build an equilibrium to this game, and then focus on the decision problem of a single policymaker within this equilibrium. So one more piece of motivation quickly. So before, many years ago, I worked at the Minneapolis Fed in the research department in the mid-90s. And our president came in and asked us at one point, what should we do? What should the committee do? What should the Fed do at this next meeting about setting interest rates? And one of my colleagues, Chris Phelan, very famous macro theorist, said, you should do whatever's optimal for you given your constraints. And it was a total Phalanism, if you know Chris at all, in the sense that it's sort of this terse, glib kind of thing to say, but it's actually incredibly deep. And the depth in it is, he's immediately imagined you're in a discretionary world, not in the world of, let's look up what the Taylor rule would say and go do that. It's, you should be doing what's optimal for you in this current moment in time, given the constraints you face. And that's what we're going to be doing today. We're going to be thinking about how can we put a little more flesh on the skeleton that Chris posed for my president back in the mid-90s of how would this single policymaker operate within this equilibrium. Okay. So the first lesson that's going to come out of the analysis is, as Lucas taught us, the private sector's beliefs certainly do depend. The private sector's beliefs of what the government's going to do in the future is going to matter. The private sector's going to be forward-looking here. It's going to be actually rational expectations all the way here. But under plausible and very commonly made assumptions, these beliefs are going to be independent of what the policymaker does today. So the policymaker can do whatever he or she wants today without affecting the beliefs of what's going to happen in the future. This is the connection that Lucas was so worried about. One of the things he was worried about in his article. But within the game theoretic equilibrium concepts, and it's very common and a very natural one, I would say, in this setting, this connection, this in effect disappears. This means that in his or her decision problem at this moment in time, the policymaker can treat private sector beliefs as exogenous. And basically a latent variable that's carried forward from the past and just another constant in however you're thinking about the impact of policy today. And now I've already started to tip my hand for the second lesson. So the first lesson is this independence lesson. And then the second lesson is, once you have this fixity and exogeneity of private sector beliefs, it means you can go about solving your problem today within this, you're the one of the sequence of policymakers by simply regressing past payoffs on past choices in states. And then you pick the reaction that maximizes this reduced form regression function in the current state. There's no need to build an elaborate model of anything. It's purely a regression analysis question. So by using game theory, we see that the policymaker doesn't need macro theory. Okay? If you apply the problem of a game apply the tools of game theory to the problem of this episodic policymaker, they don't need to build an elaborate structural, quote unquote, structural model anymore because they're not worried about invariance anymore. Okay? So the lessons here do rely on two assumptions, of course, about shocks to the policymaker's objective. These assumptions parallel those that are made in dynamic discrete choice estimation almost exactly, and they're weaker than those made in macro econometrics. And by the way, for those of you who do theory, when I gave the paper at the first time at Carnegie Rochester, there's a lot of snickering about these shocks to objectives. For those of you who are doing theory, you've got these you're ignoring the presence of these shocks doesn't mean that they have to be there in your model to fit the data. Okay? But that's why these guys do it, and that's why these guys do it, is because you have to have those shocks in there to actually mimic what's going on in the data. But in any event, given any state, these taste shifters are inducing the policymaker's choices to vary over all possible actions. And it's been playing two roles, as it turns out. Theoretically, it means that the policymaker, the private sector doesn't update its beliefs of the policymaker's strategy. The private sector can always say, well, that's because there was some shock to this taste of the policymaker that led them to do that today. It's not going to affect what they're going to do in the future. Econometrically, it's going to be very powerful. It's going to allow for non-parametric identification, which is essentially what I've already talked about here, that all we need to do is run a nonlinear, non-parametric regression here. Okay, so that's one thing. So full support, when you write down a Taylor rule with a normal error term, that's full support. Okay, so it's very commonly made in these settings. Okay, a stronger assumption I think is actually more troubling is conditional independence, that the variation in the objective, the taste shock, only affects the economy through the policymaker's choice. And it's statistically independent of all the factors that could affect the economy. And this is going to matter econometrically. So the taste of the policymaker could change for example, in the FOMC context, it could be whether the hawks or the doves are winning the battle inside the committee at that moment in time. That is only affecting the economy. How that gets turned out is only affecting the economy through the policymaker's choice. That doesn't strike me as that strong an assumption. But the other one is that how that battle is being determined is independent of all factors that affect the economy, conditional on what's observed already. And we'll talk about the conditioning. This is all conditional on sort of the public information that's out there in the world. Okay, so this is going to equate correlation and causation. It's going to allow us to use a purely statistical approach, a regression, to predict how our choices will affect outcomes today. Okay? So that's some related literature. There's a literature that goes back to Chris Sims, Sims had similar concerns with the Lucas critique to what I'm arguing here. Lipa and Jha have a paper about this as well. I'm not going to go into any details here. These papers have a very different vision, I think, of what standard policy means compared to me. And I can talk about that at coffee if you want. And Cho, Sargent, and Williams also is related. Not so much for the case they study, which is non-Bayesian learning, but for the case they don't study, a Bayesian learning is very similar to what I end up working out here. All right, so I'm going to talk about the game, talk about building an equilibrium, talk about the econometrics of the government's problem, and then wrap up. So the game. So there are going to be two players here, the government and the private sector. In macro, it's more common to think of the private sector as a collection of small agents. I could easily do that. It just adds notational complexity everywhere. Okay? I'm going to assume the government is myopic here. I'm going to relax. I'll relax that in the paper. The action in the Lucas critique is not coming from whether the government is foresighted or not. It's all coming from where the agents are farsighted or not. And that I'm going to have. The private sector is forward-looking here. I'm going to play an infinite period dynamic game. So there's 7 stages to this game. So you're going to, and this is where all the action is. So stage 1, we're in a single period of the game. We all come in at the beginning of the period and we observe a state variable. The state variable has all the usual suspects in it. Capital, a distribution of wealth, maybe a sunspot variable if you like that. I gave this paper in front of Roger Farmer. You want to know if sunspot variables were allowed in there? They're in there. Okay, so anything you want is in X. So then the government privately observes a non-economic taste shifter theta in stage 2. And as I say here, it's similar to the error term in the monetary policy rule, or utility shocks in dynamic discrete choice. It's very easy to motivate, what you want this to be. And it's going to be drawn from this set theta, some capital theta, according to a full support density. So full support means that every possible outcome in theta is allowed, conditional on X. Okay. So the set of what can happen isn't depending on the state variable. Okay. Now, the likelihood of the things could, of course, depend on it, but the set of what can happen isn't. Okay, so this is all similar to New Keynesian, our dynamic discrete choice econometric modeling. Stage 3, the government chooses publicly its action. And then stage 4, the private sector will choose publicly its action from. Okay. So these are the first 4 stages. Now, here's the key thing, or a key thing, that the economic outcome is now drawn from some set of possibilities. And if you look at this conditional density, it depends on X, it depends on the choice of the government, it depends on the action. This probably has a pointer, so I don't have to always go to that. Yeah, so there's no theta here, right? There's no theta here. So that's meaning that theta doesn't have an independent influence on the conditional density of Y. It doesn't affect Y. The only way it's going to affect Y is through G. Okay? So theta is going to influence the government's choice of its the taste shifter is going to affect the government's choices, but that's the only way it affects Y. Within period payoffs are realized. Government gets some payoff here. I could add X to this if you want, but that doesn't matter for anything. And then the private sector gets its payoff as well. Okay. Next period state is drawn. Again, we see this conditional independence that theta is not showing up after this line. Okay. And so through notation, powerful assumptions get made. The density, again, has full support over, now this is a full support, different kind of full support assumption over transitions to the new state variable. All right, so I went through that very fast. The basic example I have in my mind always is choosing interest rates, whether to raise or lower interest rates, and that's what's, and then the X's are just all the information you might have about the economy. Okay. And then Y, for the Federal Reserve, Y is simply unemployment and inflation. That's really basically the only outcomes they care about. Okay. In Europe, this supposedly is only about inflation itself. It's the only thing that matters. Okay. So all the information. So the couple of things you might want to keep in mind here. All information about future theta is embedded in the public state variable X. This means that your choice today can affect what happens in the future to your tastes, but it's all publicly observable. Okay, so there's no, when you enter a period, it's not like the government thinks, I know more about what I'm going to be doing in the future than the private sector does. They all have common information. This is, gets rid of some interesting and important things about reputation that the government might be more of a dove than they're letting on the inflation front. But I'm not going to, I relaxed that in the paper. I'm not going to talk about that in the talk. I basically, all the transitions from X to X prime are possible, regardless of actions. This means allows for non-parametric identification. You're going to see all the possible X's in the past data. Okay. This is the bigger deal, I think, in all this is this conditional independence assumption. The taste shifter is only affecting the outcome Y and the future state X prime through the government's choice of policy. And if you're into the causal inference literature, this is really 2 assumptions, as you know. It's random assignment, so the theta is independent of any other shock that's affecting Y, and exclusion, so that the theta has no direct effect on Y or X prime. And I think here random assignment, which I think is you go to the causal inference literature, the applications thereof in the micro literature, this is probably the one they worry about more. Here, this is probably the one we would worry about more. Excuse me, they worry about this one more, and less about random assignment because they're randomly doing things. Here, random assignment is the one we would worry about more. Okay, how much time do I have left? Okay. Okay, so the private sector, now I'm going to build an equilibrium. So I've described the 7 stages of this game, and it's going to be repeated every period. I'm now going to build an equilibrium to the game. Private sector is going to be forward-looking. Its choice of actions affect both the current Y and its future X prime. So if you go back to the various stages of the game, its choice of A is affecting both what happens today and what's going to happen in the state variable. So they have to know they have to form beliefs of what's going to happen in the future in terms of government choices to know how different x primes affect their payoffs. Okay, so the optimal choice of A depends on the beliefs about future government play. Now, I'm going to start with out of equilibrium in some sense. I'm just going to posit the private sector believes the government follows a Markov strategy of some kind that depends on the state variable and its taste shifter, and then chooses a G. I'm going to assume that gamma hat, this strategy has full support. Now, what full support means is that for any x and any g, we can find some theta to rationalize that g. So give me an x, give me a choice of g. You can always say, well, that's because they saw theta today. And that means that you don't have to worry about its influencing what the government's going to do in the future, okay, if you're the private sector. Because it's just this theta. It's not anything about future thetas. And this can be, if you go to the paper, it's easy to justify, if you want things to come from primitives, you can easily do that through appropriate assumptions about the objective function. Okay. Now, this is sort of weird if you haven't done dynamic games, but it's very natural for those of us who've done that. And this is pretty important, too, that it's standard in Nash equilibrium and the refinements thereof for private sector beliefs to be concentrated on a particular strategy. So when you solve for a Nash equilibrium, when you're doing game theory, you solve for one strategy for every player. And those strategies are common knowledge. So everyone's beliefs are focused on those strategies. So that means that no matter how unlikely the history of government's choices seem to be, they pick low interest rate, low interest rate, low interest rate, low interest rate. And no matter how dovish it looks, you never change your beliefs about what they're going to do in the future. They'll respond to the future in the same way. Now, we can argue about how realistic this is. It's actually was a description of what happened when under the Bernanke and Yellen Feds in some sense. They kept choosing low, 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 and inflation expectations didn't move at all, meaning that people didn't doubt on the future inflation fighting reputation of the Fed. But just in the game context, which is what I'm emphasizing, the theory side, people's beliefs are concentrated. They only have one strategy in their heads. And so that means that the private sector is never going to update its beliefs of a government strategy, no matter what it sees. Its continuation value will be a fixed function of next period state. And its strategy then is only going to be a function of two things, the x today and the g that the government plays. So now we start with a Markov belief, and we conclude the strategy for the private sector is Markov. And then the government strategy, given if it believes that the private sector's strategy is Markov, and I'll just whip through this, government is myopic. It's just going to maximize taking this best response as given, and it's just going to choose as a function of x and theta. So that's the only thing that's going to be affecting his choices. So to summarize, we end up with the following situation. Government has a Markov strategy. And this is, in fact, the rule that's in the heads of the agents at all times. Okay? This strategy for the government is in the heads of the agents at all times. The private sector has a strategy alpha star, and then, well, by assumption, but as I say, you can justify the strategy has full support. All right, econometrics. So at this point, I'm going to make a slightly, very different informational assumption. Up until now, we've had these two players playing this game. I'm going to say that I'm going to now drop the government's assumption, the assumption the government knows everything about the private sector. It's going to. This would be what they would usually just maximize in the game. Their payoff, given the outcomes of Y, given the strategy of the other player, the private sector. But I'm now going to assume, quite realistically, the government doesn't know piece of Y, which is really the structure of the economy, how Y is determined by everything in the economy, the choices of the private sector and the government's own choices. And it doesn't know alpha star, doesn't know the strategy of the private sector. And this is what we actually spend a lot of time in macro trying to build, is the models to figure out these things. I'm now going to assume that it doesn't know that. All it sees is it knows its current x and theta, it knows the past x's, the past g's, and the past y's. Okay. And knowing just this information, I'm going to say it's going to be able to solve this problem without knowing all of these things. It's not going to have to know a piece of y and alpha star to solve this problem. So how can the government use its data set to solve its problem? It first defines its payoff as a function of the past data. So it keeps the current data, but then it looks back at all the g's and the y's, and now it forms payoffs, but using today's data. That's important. It's current case shifter. It then does a nonlinear regression of these payoffs on the g's and x's in the data. And then it just maximizes this regression function. Okay, so that's what it can do. It's very simple. Now, why does this work? The main thing is it's seeing all the possible g's in the past data because of full support. So if you give me it's seeing all these thetas for a given x. It's seeing all the possible g's because of full support. And so give me an x, you're seeing all the g's that have taken place in the past. And the private sector beliefs in this strategy are fixed. Those are just latent variables. It doesn't matter what you do. So you can just use the past data as a source of information. And the conditional independence here matters a lot too. The g is varying in the data for only one reason, the variations in the theta. It's not varying because the government, because of any other reason. And so the case shifter here is only, as I've emphasized several times now, is only affecting the outcome through the government's own action. And this means that the conditional expectation, the regression function of the payoff in the event that the government chose g in the past, is exactly the same as the policy projection, the payoff of the government chose g today. Okay. And this is because the thetas that are leading the government to choose g are not influencing the government's payoff in any way. It's only the g choice itself, and so you can just use this regression. Okay, so this is the key equivalence that allows the government to do what it wants. So the finite case is the easiest to understand. Suppose everything is finite. Consider any choice g, and then look back in the past at all the outcomes, the data, that where g is equal to the g you're considering, this little g, and the x's are what they are today. And then take the average payoff of w. What's going to vary here is y. As you look past the data, the y's are going to be varying over those observations. You take the average payoff over that. Now, for every g, you can calculate this average payoff given your x, and you just optimize with respect to g. So that's what you do today. You just optimize this function given with respect to g. Okay. So I'm not going to repeat all this. A lot of people in macro like theory. I'm certainly fond of it myself. How can you build theory into this? Where would the role for theory be? Basically, it's the usual thing. I've described a completely non-parametric approach, but in the real world, that requires a ton of data. In reality, you might want to be able to have use of less data, or maybe this conditional independence restriction is only satisfied some of the time. Then what I show in the paper is that you can use theory as a source of functional form restrictions. That's connecting the limited amount of data you have. It's a way to extrapolate, okay? But the key of this is the theory you would use would never be this fully structural apparatus, this massive structural tool that, because you don't need everything to be invariant. All the structurality of our modeling devices in macro are coming from the fact that you want things to be invariant to policy regime choices. You don't need that to generate useful functional form restrictions. Conclusions. Okay. So over the past 40 years, we've been focusing on rules and regimes. It's led to increasingly complex models based on increasingly rich data. I think it's been a very fruitful endeavor in many respects. But it's not useful for most policymakers most of the time. They want to know, what do I have to do today? What should I do today? And the right answer is never, well, just go look at the Taylor rule and figure it out. And it's never, no, that's a stupid question because you should be choosing regimes, which, by the way, I've heard both of those things and when I asked academics for their input. Few policymakers, you don't get to choose among regimes. Instead, you want policymakers, you've got to be thinking about within an equilibrium, how do you do the best you can? I think this leads to a much more statistical and less theoretical approach to thinking about policy making. It's really about what are the sources of variation past policy decisions, what kind of functional form restrictions on within equilibrium payoff functions seem reasonable and theoretically valid. But and this I think will tie also what's being done on the policy side in micro with what's being done in the policy side with what I would think should be done on the policy side in macro. So it seems like if we want to follow this within equilibrium approach that I'm describing here, we could borrow a lot from what's happened on the micro side. Okay, thanks a lot.